Good morning, and welcome to this latest series of Cogen Europe's Power and Heat Boost webinar. Very warm welcome, pun intended, I guess. We're very pleased to have you. My name is Hans Korteweg, and today we will be looking specifically at the Spanish cogeneration market and specifically energy hybrids, looking at powering industrial competitiveness, resilience, and decarbonization. If you recall and you have been following what's been going on at Cogen Europe for the last couple of months, we came out with an extensive study on the 23rd of April looking at the role of cogeneration or flexible and hybrid cogeneration between the period of 2025 to 2024. So part of that study looked at 5 specific use cases, and the first use case that we're happy to go into more detail with is in Spain specifically. So we have an excellent lineup of speakers, including some use cases from a number of OEMs, a panel discussion with different perspectives to share, and then of course we will also get an introduction to the Spanish use case. Just to let everyone know that we are recording this presentation, and there will be opportunities to ask questions. So please don't be shy and do use the Q&A function. You can pose questions throughout the webinar, but we'll have a period at the end when we can take those questions as part of the panel discussion. So without further ado, I'm very pleased to welcome Gerald O. From Compass Lexecon. He is the Vice President for the EMEA Energy Practice, and he's been working with us on this study over many months and years. I'm very pleased to welcome you to the floor, and please feel free to share your slides and begin.
Thank you very much, Hans. Good morning, all. I'm trying to share my screen. You should be seeing my screen now.
It's coming. Yes.
Okay, so good morning. Thank you for the opportunity to present, as Hans introduced, parts of the study that we've done for Cogen over the last year, and looking specifically into the Spanish use case that we've modeled here. Plan for today would be to provide a bit of a background to the study, then go into the use case that we have modeled, explain a bit what we've done here, then look into selected case study insights, so what we found and can show with this case study, and conclude with some summary of the conclusion, and hand over then to the panel. First of all, background to the study. We were approached by Cogen to provide some insights on the future of cogeneration, and that's against the background of there being quite significant cogeneration capacities in Europe, and to some extent the discussion on the European level, and not only with politicians, is always whether this can be replaced and electrified, and the question or the proposal by Cogen and the cogeneration industry is to rather hybridize these cogeneration units and work in tandem with electrified heat instead of substitution. And that's what we are analyzing here in this study. So we're trying to provide evidence on the role of cogeneration in the European energy sector against both the decarbonization targets that are ever increasing, but only against the realities of the framework conditions that we see in Europe, where we have an ongoing and not completed energy sector transition, and where we also have the need for end users, and in this case, industrial players, to remain competitive in what they're doing. In providing this evidence, we've selected and discussed with Cogen a study setup that analyzes dedicated use cases. So we've selected some use cases across Europe, and in all those use cases, we have modeled 2 scenarios or 2 setups, one that uses cogeneration and hybridizes this with electrified heat, and another setup for the same use case that uses a setup that does not include cogeneration, and thereby we're able to show what the role of cogeneration is and what the advantages of cogeneration is. And we do this across 5 dimensions that we see here to the right, and it will to some extent guide the remainder of my presentation. So we look to what extent these cogeneration technologies can complement electrified heat. We look what the role of cogeneration in achieving energy efficiency is, how cogeneration can contribute to decarbonizing the energy sector, how in this industrial use case competitiveness can be supported by the usage of cogeneration. And we also look into the wider system impact of cogeneration by providing particularly ancillary services to support the wider grid. We have, as mentioned in this study, looked into 5 use cases. So these 5 use cases cover a broad range of both industrial and district heating applications, and they also cover various European geographies that are to some extent the endpoints of the energy sector transition as we see it in Europe at the moment. So we have already quite advanced countries like Spain, where we have a lot of renewable electricity already at the moment, a lot of intermittent renewable generation like solar and wind. And we have other countries that are relatively at the start, like Poland and Romania, where we still have a lot of fossil fuels in the energy mix. And by looking into those 5 use cases and 5 case studies, we can cover a bit the breadth of the energy transition that we see at the moment, and provide some broader insights on the usage of cogeneration within the evolving energy system. We will look into the Spanish use case in a bit more detail in a moment, just to give a glimpse on how we did the modeling. So we analyzed the use cases not in a moment view, but rather over the 15 years until 2040. So we covered the entire transition from today until 2040. And we do this by looking into the impact of cogeneration in a certain country within the European energy system. We look into the involvement both in demand and generation. So we take fully account that the energy sector transition is continuing and ongoing. We also take into account that the commodity prices, and especially the carbon price, will change over time. And we model this in hourly granularity to also take into account the short-term flexibility that cogeneration technologies provide, but also the flexibility needs that the energy system does have on also shorter-term granularities. And we do this taking into account the weather conditions that we see around us. So the availability of a lot of renewable generation at some points in time, and the lack of renewable generation in other points in time. So that's the framework. There's in the full study, there's a much more detailed description of the modeling approach that we use, but that's just to give you a few of the key elements of how we modeled the use cases. So now a quick view into the Spanish use case without going into too many details, just to flag what we have done here. So we look into a Spanish chemical industry player that currently uses cogeneration and that has a need for steam, electricity, and covers them currently to very significant extent by using a simple cycle gas turbine. And the setup that we've looked into then moves toward hybridizing this setup. So we have, again, the simple cycle gas turbine. We also have the backup gas boilers that were there in the past, but we over time hybridize the heat generation ability by including an e-boiler that can make use of electricity both off the grid and from some limited solar PV on-site generation. And we also include some heat storage, and thereby we allow an interplay between the gas turbine and the electric heat generation. In the second setup, where we basically restrict the options available to the industrial end user, we remove the simple cycle gas turbine and then take a look how this would play out. So the industrial player would be limited to basically the usage of an e-boiler and the backup and usage of a natural gas boiler in case of non-availability or non-commercial viability of electrified heat. And we again include also the heat storage. So in this setup, we thereby can isolate the impact that the simple cycle gas turbine and the CHP setup has on the heat provision of this industrial player. Also, maybe to flag, when we look in the heat demand or in the energy demand of the end user, we have both low pressure steam demand, high pressure steam demand, and we have a relatively flat demand profile. So we have a process industrial player here that needs heat and steam and also electricity more or less throughout the year, with some very brief interruptions over time. But this is a relatively baseload application here. And we can flexibilize this to some extent by using the heat storage, but overall there's like quite significant need for baseload supply here. Going into the case study insights, we have here a brief overview of all the dimensions that we analyzed, and that's a replay of the 5 dimensions that we've already outlined before. I will not go into all the details here. For most of those aspects, we do have additional slides, and I will run you through them in a moment. But just to show, we analyzed the complementarity of CHPs with electrified heat, both on the short run and in the long run flexibility perspective. So how the availability of CHPs can complement the interruptible or intermittent availability of renewable electricity. We also show the impact of CHPs during times of high energy prices, which are set to remain also in future. We also, in regards of the complementarity, look into the grid connection queue issue, which we understand from the discussion with the Spanish colleagues is a very significant issue in Spain, and to some extent hinders electrification. In terms of energy efficiency and both decarbonization, we basically show that by using CHPs, the use of direct and indirect fossil fuels and the connected emissions can be reduced. So we look into both the emissions that are on site from burning gas, but also the emissions in the energy system, in the electricity system upstream, to provide electricity also when there's no renewable generation. And over a large time of the analyzed horizon, the CHP setup performs better in both dimensions. And we look into the energy cost for the end user, where we can show that using CHPs is overall more competitive than using pure electrified heat or electrified heat backed up with gas boilers. Finally, there's a wider system impact that we're not going to cover in much detail today, but by having a gas turbine in a CHP configuration, there's also the ability to provide some ancillary services and wider system impact. Looking into some of those aspects in more detail, and what you see here are now some of the dedicated case study slides that are part of the study, and I've picked a few for this webinar to run you through. That's basically just a view into the dispatch of the 2 setups. So we have on top end the setup using the CHP. We have at the bottom this setup that does not include a CHP. And we look both in how electricity is provided and how the heat or steam is provided. What we do see here is that depending on the, we're looking into 2040. It's also important. We're looking into 2040. So basically at the end point of the electricity system transition in Spain. And what we see is that during times when electricity prices are high and electricity prices remain high in Spain at some points in time over the year at least, there is still the usage of CHP when electricity prices are low, and that's like quite regularly the case still when there's like a lot of renewable generation. Then there is a lot of off-grid or grid-sourced electricity, where basically the e-boiler runs on cheap and almost free electricity. And when this cheap electricity is not available, there's like the heat provision by the CHP and natural gas post-combustion burner plus the electricity the heat storage. So we basically have a complement of all technologies that switches quite quickly over time to meet the heat demand. And when we have excess heat, there's also the ability to store them and use them for later time. So that's a snapshot of a week in 2040. We have then aggregated this like hourly modeling that we've done over time for all the years that we looked into. We again have like both the CHP setup, that's always the left-hand columns over time, and with the non-CHP setups on the right-hand side. And when we look into how thermal energy, so steam, is supplied over time, then we see that the CHPs do have a quite important role at the moment. So 2025, they have a quite high runtime. And when we look over the years until 2040, then we see, on the one hand, a decline of the usage of the CHP to provide the steam required. And that's also to be expected because the number of hours where there's cheap electricity available increases. But crucially, we do see that also in 2040, there's still quite a relevant share of heat that's actually provided by using the CHP. And in the non-CHP case, the interesting thing is when we look into, and that's something we cover in more detail in the next slide, but we see when we offer to the end user an electric boiler and a gas boiler, then there's still quite a significant amount of hours of the year where there is the usage of the natural gas boiler because it's the cheaper solution. So even in 2040, with a lot of renewable electricity, there's quite some time where there is the usage of the gas boiler. When we look into the dynamics over the year, then we compare here what's happening in 2025 and what's happening in 2040. What we see is the electricity price structure here. So basically the duration curve of electricity prices in Spain. We see that we have some negative hours and then at the lower end of the curve, very high prices. When we look how thermal energy demand is met over those like 8,760 hours of the year, then we see in 2025 we have like some hours on the left-hand side of the chart where electrified heat is like the cheaper way of producing it, and we have like quite significant hours where the CHP is still the cheaper way of producing or meeting the heat demand. When we look into 2040, then we see that there's a quite significant shift in the price duration curve. So the continued renewable deployment leads to a change in the price structure and the prices over the individual hours of the year. So we have a much longer period of zero or even negative electricity prices, a broad area of quite significantly reduced electricity prices. But we have at the right hand still a relevant number of hours where electricity still remains quite cheap, quite expensive, as we do not have renewable generation over those hours. And when we look into the impact of this structurally changed and shifted electricity price setup, then we see that the usage of the technologies changes. So we have like a much more pronounced use of electrified heat, but we have at the long end still a quite relevant usage of CHP in the mix, and basically can still show and still see that using CHP is a cheaper solution in quite a relevant number of hours of the year, even when we have a quite advanced decarbonization path already. Moving ahead, there is one aspect that's particularly pronounced in Spain, and we've looked in the studies we mentioned in 5 jurisdictions, and I think Spain is the one where it is like particularly important, and that's the issue of grid connection queues. So that's basically holding back electrification to some extent, because the grid connection capacity that would be required to move to electrified heat is not or not immediately available. And what we can show here is that by moving or by renewing existing CHP capacities, we can actually delay the need for electric grid connection capacity. So we basically move initially to reinvestment of the CHP, use hybridized heat generation within the existing grid capacities. And when grid capacities are available, then we move to what we call full capacity electrification. So where electric heat is deployed to an extent that it allows the complete substitution of all heat generation. We do not have to substitute it in all time, but we can. And this is then possible after I think 10 after 10 years. We basically say there's the grid connection availability, so we can move to full capacity grid connection, and that's something that, as we understand at the moment, is actually not possible immediately. So the fully electrified heat generation is something that's to some extent theoretical at the moment, because an industrial player would not be able to do this immediately. Then moving ahead to fuel consumption, and the logic is then the same also for emissions. So what we've looked into is how the setup without a CHP available compares to a setup with CHP usage. And we do take a bit of a broader view than just the on-site usage of fuel. So when we compare these two cases, we look into how much natural gas or methane is used on site, and this on-site usage is either by the CHP or by the gas boiler. So that's the usage of methane on site with the industrial player. But being part of a broad energy system, when the industrial player does not have a CHP in place, there's also usage of off-grid electricity, as there's a lack of on-site electricity generation by the CHP. And when this electricity that's taken off the grid, and we need to keep in mind the industrial player has a relatively baseload demand, so he needs electricity and heat not only at times when renewable generation is available. So when there's like offtake of grid electricity in times where there's no renewable generation available, then this might be and is regularly produced by fossil fuel generation. So in Spain, usually gas-fired generation. And then this produces also some CO2 emissions in electricity production. And this marginal emissions and the marginal fuel consumption here is something that we take into account. So we basically compare an energy system where there is a CHP with the end user with an energy system where there's no CHP with the end user, and on an hour-by-hour basis look how this like availability of the CHP would change the generation of electricity in the broader system, and how much fuel is used for this marginal unit of electricity that is required to cover electric need by the end user that's not provided by the CHP. And with this long intro to the results, what we basically see is that especially in the earlier years, we have quite relevant contribution of fuel saving by using on-site CHPs. Using the CHPs avoids the usage of gas in the power system over most of the years. It gets a bit less important at the end of the years, but that's also to be expected when we have ever more renewable generation deployed. The impact of using on-site gas-fired generation declines over time. And we see the same picture also with the emissions. So that's basically the flip side of the analysis before, where we look into how much emission is produced on-site by using the CHP, versus how much emission is produced in a case where we do not have a CHP. So we have again on-site emissions, but we also have again marginal power sector emissions, and we see the same picture. We have like a relevant impact in the first years, and the impact is like trickling off a bit in later years when there's more renewable generation available in the system. Last aspect is the cost side of things. So having this model in place, looking in over 15 years, we were able to also analyze the cost and revenue side from this two setups. So again, we have in purple here the CHP setup, where we have like higher upfront investments in the setup, and then over time have both like running cost, so fuel cost and operating cost, but also do have some revenues from selling electricity on the market when it's in excess production on site. And we compare this with a non-CHP setup, where we do have basically investments and running costs as well, but do not have any revenues from selling electricity. And when we compare this over the 15 years and provide like what we call levelized cost of energy to both meet the electricity and heat demand of the end user, then we see that under the assumptions that we've taken here and that we've outlined in the study and presented very briefly also here, that the CHP actually leads to lower levelized cost of energy. So again, meeting the end user's energy demand is more competitive by using the CHP, despite there being a bit of an increase in the initial capex, which is also to be expected. And we note that this is also to some extent a conservative assessment, because we do not take into account revenues by the end user that he could make from using his CHP to also provide and monetize ancillary services. So that's the overview over some insights. And then just to summarize, we've looked into the whole study into those 5 use cases. The one that we've discussed here is the chemical industry use case in Spain. And from this study, we basically can show that in the setups, the use of CHP can provide some benefit in the dimensions that we've looked into. So we can provide some support, some impact on the complementarity. We can avoid the usage of electricity at high prices. We can reduce the impact of grid connection queues. We can use energy more efficiently. We can use methane and gases more efficiently than without CHP. We can thereby contribute to decarbonization. We can provide a solution that's more cost competitive than solutions without CHPs in place. And we can provide a wider system impact because we have a rotating generation equipment that can provide ancillary services to the system. And in many jurisdictions, most of those services are also a way to additionally monetize and provide an additional revenue stream to the system. So that's it. Thank you very much. If there are questions, I think that's a good moment now to raise them.
We don't have any yet. So just a reminder to all our participants, you have the opportunity to type in your questions through the Q&A function. So if we have none now, there's still an opportunity towards the end of the webinar to have your questions answered by our experts. So thank you, Gerald. for your introduction and overview of the Spanish use case. We will now move on to some additional use cases, looking at the combination of different technologies, so specifically CHP and heat pumps and so forth. And we're very fortunate to have two speakers with us today. The first is Andre Bandkin, who's the managing director of 2G Energy International, and he has a number of examples that he'll be sharing with us. And then our second speaker under this framework is Klaus Parhuber, and he's the strategic project development manager at INEO Group. So we're very pleased to have these two experts with us to share their experiences, their company's experiences with hybridized technologies. I'll begin with Andre. So if you can, please share your slides.
Yes, thank you very much. You can hear me just fine?
Yes.
Yes, you can. Perfect. Okay. And now you hopefully also can see something.
Yes.
Which you can, oh, perfect. It works. Look at that. Okay. Everyone, thank you very much for joining today. I'd like to quickly introduce a few cases of CHP and heat pump in combination in different scale. Quickly about our company, 2G. Since 30 years in the market, 10,000 cogen systems installed worldwide, give or take. Half of that in the waste to energy application sector, so biogas application, the other half in the industrial and commercial sector. Since 2023, we also have heat pumps in our portfolio. You can see that here in the middle, 88.9 to 3,200 kilowatt of capacity for various applications. And more and more, especially here in the European market, we see customers going for a combination of these units. How they're typically applied, I mean, in Germany at least, a lot of that is going for district heating, admittedly. So what we call municipal heat planning, where you essentially, as you can see that here, have your CHP system combined with a heat pump, buffer heat storage that then supplies various consumers. But that's on the municipal scale. So for residential, light commercial sector, the hospitality industry, these kinds of application. Gerald already mentioned the advantages of the combination, better heat prices, a more adaptable and expandable on-site energy solutions. Obviously, you're looking at heat pump, you can use various heat sources, so ambient air, river water, wastewater switch is an application that is often looked at the moment, but geothermal sources obviously are possible as well, and depending on which fuel you're using for the CHP side. So if it's natural gas or biomethane or future fuels like hydrogen injection into the future, you can also increase the renewable energy share of your of the electrification side. To give you a bit of an idea on the general application there, we see cogen and heat pumps as natural partners, not as competitors. These integrated systems increase the overall efficiency of the heating supply, and obviously it gives customers the flexibility to use the self-generated electricity. Example given for the heat pump when market prices are low, so playing with the power price tariffs, as was mentioned earlier. Now, how is that typically applied? This is a residential commercial scale approach. Just very briefly, 50 kilowatt small scale cogen system with 100 kilowatt thermal output, which we then scale up to 260 kilowatt thermal output with an additional air-to-water heat pump that is either supplied by the cogen system or by the power grid, depending on the tariff, with an average operating time of 5,000 to 6,000 hours a year. But that's small scale. Looking a bit more in the industrial sector, this example here, that is from the food processing industry, not from the chemical, but a similar setup. So demand for high temperature process heating, 24/7 energy demand, strong push for decarbonization, but also, as we say, high quantity, low margin business. So every cent of energy saved counts. And what we basically did here is we provided a turnkey approach where we have a CHP unit with two different heat pumps, so an air-to-water and an air-to-air heat pump, in a combination to boost further the supply temperature up to 100 degrees centigrade, including a buffer storage tank to essentially decouple generation from demand. So essentially, the CHP provides the electricity and high-grade heat when the demand profile or electrical price rewards it. The heat pump lifts the environmental or waste heat, as we call it, when electricity is relatively cheap and the CHP running time is constrained. And the buffer storage essentially decouples these two from each other. The controller manages, or the customer control manages the storage dispatch and grid interaction there, so that it's a fully flexible, integrated solution that tries to maximize the utilization of the energy tariff system. On an industrial or even a utility scale, that's a similar setup here, a little bit bigger, more akin to what maybe a chemical plant might need or a pharmaceutical plant might need. That's 10 megawatt of cogen capacity, 5 million liters of thermal storage, 2.8 megawatt of heat pumps, so 4 air-to-air heat pumps in total. And this is connected with a 3-kilometer pipeline to a district heating network that not only provides residential heating, but also provides also to industrial customers, including a nearby shipyard facility. The Meyer-Werft in Papenburg, some of you may know that. They're making luxury cruise liners. So where also this plant takes over their heating supply. Looking at it from a European context, from our point of view, we have several use cases here that we typically identify at the moment as sectors where there's a strong demand. I mean, district heating, we already mentioned. Commercial property is also certainly a sector. In the manufacturing industry, definitely the push for process heating to 100 degrees centigrade, including waste heat recovery, is what people on the heat pump side are most interested in. And at the same time, the CHP unit is capable to provide the electrical power for that process while the heat pump lifts the waste heat, especially looking at countries or territories where power supply by the grid is congested. Yeah, if we look at other countries, availability of power supply has become an issue. So the on-site generation in case of grid constraint by the CHP unit can be a big support for the further electrification of the heating site by heat pumps for various applications, if it's in the biogas sector or the industry, or as we call it, object supply. So it really depends which individual use case, which country, which territory, with which power tariff structure you're looking at. But typically, in almost all cases, there is a commercial use case to be made. Looking at the time, that's it already from my side. So thank you very much for listening. And obviously, if you have any questions later on, please let us know. Thank you very much.
Thank you, Andre. Much appreciated. let's move on to our next speaker. So I'm very pleased to invite Klaus, who is the Strategic Project Development Manager, as I mentioned, from the INEO Group. So Klaus, the floor is yours. Hopefully you can share your slides.
Yeah, hello everyone.
We can hear you, and your slides are there. Yeah, the floor is yours, Klaus. Thank you.
Thank you very much. Yeah, my name is Klaus Pajowa. I'm working for INEO Jenbacher, and we are a manufacturer of gas engines in the megawatt class and do big power plants with our engines, and more also combined solutions, as you see in this picture, hybrid solutions, and the engines are an ideal combination with the volatile renewables. I have a typical use case here from Germany, where we combine a CHP with heat pumps. This is quite common in Germany over the last couple of years, and several customers did this combination. It shows two CHP units with 4.5 megawatt each, and it shows two heat pumps. In combination, and each heat pump is producing additional 1 megawatt heat output. And the interesting thing is where the heat is coming from. This is an optimization of the CHP and increasing the heat output by using an extra heat exchanger in the exhaust. I call it condensing heat exchanger because we're cooling down the exhaust to temperatures well below 50 degrees Celsius. And the second heat source is generator cooling. Generators of these engines are typically open air ventilated cooled. So the cooling energy is going to the ambient typically. But we have a solution to capture this cooling heat and use it as a heat source for the heat pump. The result is we have two engines with 4.5 megawatt each, producing more than 4.7 megawatt thermal energy, so high temperature heat for district heating. And with these heat pumps, we add another 1 megawatt of heat. So that increases the total heat output to 5.8 megawatt per unit at 105 degrees Celsius district heating water. We, from Jenbach, we supply also the SCR system and the heat exchanger to allow us giving performance and emission guarantees. And the heat exchangers in the exhaust are here a special arrangement with two heat exchangers plus one condensing heat exchangers, as I mentioned before, to cool down the exhaust well below 50 degrees Celsius. That allows to run the engine still on very high electrical efficiency of 46%. And the total efficiency, what we can achieve in combination with the heat pump, is almost 95%. And the COP of the heat pump is here almost 6. This is because we are using the heat pump to use the waste heat at around 50 degrees Celsius and pump it up to 60, 70 degrees Celsius and implement it to the whole water steam cycle or water cycle to optimize and achieve the 105 degrees Celsius district heating temperature. Going forward, how do we see the future of CHP and the integration of heat pumps? Now we are working more and more with high temperature heat pumps from Heaton. And Heaton is a company that is specializing on piston compressor solutions, producing high temperature heat pumps with 2 stages of heat pump, depending what temperatures are available and what temperatures are required on this heat sink. So they do 1 stage, 2 stage, plus the second stage could be a mechanical vapor recompression solution to allow increasing the steam pressure to what is required. typically low pressure steam, 6, 7, 8 bar, what is required and what fits very well to heat pump solutions. Temperatures all the way up to 200 degrees Celsius. 200 degrees Celsius would be higher steam pressure, already up to 15 bar, something like that. So it really depends on the heat source, what is available, what temperature level is available, and what is required on the temperature, and is it heat, hot water, or steam. Depending on this, the configuration is a 1-stage, 2-stage, including mechanical vapor recompression. And of course, depending on this, the refrigerant is selected to achieve the best solution, the highest COP. One example how this could look like is shown here. This is an example for paper mill applications. Here we're using a biogas from a paper mill, from a waste generating a biogas in the paper mill itself. And this biogas is available for the engine, run more or less a biogas engine. The example here is a 1.3 megawatt engine. And the engine exhaust is used to produce steam for the paper mill. And here we're producing 1.3 ton at 5.4 bar. This is the steam what we can produce with the engine exhaust gas typically. But now, in this case, we are adding a second steam boiler at 1.4 bar, and the waste heat, the cooling heat from the engine, you see here on a heat exchanger 2, 3, and 4, is used as a heat source for the heat pump. That's the yellow circle in the middle. And the heat pump is then producing also low pressure steam at 1.4 bar with the result of 1.9 tons. And then we use a compressor to increase the steam pressure to 5.4 bar. And this concept allows us to increase the steam production by another 2.4 tons per hour. And in the result, we have then, instead of 1.3 tons, 1.3 plus 2.4, in total 3.7 tons per hour of steam production. This is a significant increase of steam production and typically what is required for industrial applications. And what we're combining here is a high efficiency gas engine. So we are converting the gas at very high efficiency, well above 40%, between 40 and 45% typically, electrical efficiency, with high amount of steam production. And this is a nice solution going forward. What was the typical application for this in the past were smaller gas turbines, because they had a much higher exhaust energy and could produce this amount of steam. But with this combination, we have a very high efficiency solution plus a very high steam production. Also, what we see in the future in terms of flexibility with CHP and heat pumps is shown here. In order to maximize the heat output, using gaseous fuels, and it could be natural gas at the beginning, it could be biomethane or hydrogen in the future. The best solution is to use this gas in a CHP to produce power and heat. Because if you use gas in a CHP, you're producing electricity, and this electricity can be used to run a heat pump, depending on COP between 2 and 5. With high COP, you can maximize the heat output to 270%. based on the fuel input. And on the left-hand side, you see an engine CHP with high electrical efficiency. That's the advantage compared to other solutions like micro gas turbines, which have typically lower electrical efficiency. The worst thing is to burn the gas just in a boiler, because then the maximum heat output is around 100%. You can do condensing, go a little bit above 100%, but that's all. The combination with heat pump allows you much more heat output based on the fuel input. And the last slide I have in here is the data sheet of from Heaton. What they are having in their portfolio is a 4-cylinder version of the compressor, and they're working on bigger solutions with bigger 16-cylinder compressors, producing a heat output in the range of 3 to 10 megawatt per unit. Yeah, that's what I have for this combination of CHP and heat pumps. Thank you very much for your attention, and happy to answer any questions.
Thank you, Klaus. Thank you to you and to Andre for sharing those different examples and case studies, combining different technologies, hybridizing different technologies, and really maximizing the efficiency of the combination of the different technologies. So thank you for that. So we don't have any questions yet, but there is still time. I suggest we move along now to the panel discussion, where we'll focus more specifically on Spain and sort of reacting to what was presented earlier by Gerald in terms of the Spanish use case as part of the Cogen Europe study. So I'm very pleased to welcome 3 panelists. We have Ricard Villa, who's representing both Cogen Spain and Acogen. We have Valentina Gonzalez, who is the Energy Solutions Director at Ignis. And finally, we have Nikolai Romanovsky, who is the Senior Energy Manager at CEFIC, the European Chemical Industry Council. So we're very pleased to have the 3 of you with us. I understand that we will start with you, Ricard, and that you had a few slides that you wanted to share to illustrate your points. So I suggest we start with you, Ricard, and then Valentin, and then Nikolai.
Yes, thank you. Well, thank you all. Thank you, Gerald, for the presentation. Let me share my screen. I believe.
Yes, you just need to go to full screen mode.
Yes.
You're in presenters mode.
I believe it could be written. There's a lot of numbers in. It's a little bit repeating what we discussed in Brussels when we present the study, and focusing a little bit some sort of numbers for the role of transition that CHP can do, and that the study shows. We saw some sort of numbers that are showing that CHP can provide savings in terms of CO2 emissions against the some hours, some mix in the electricity sector, that can provide some economical competitiveness in the energy cost, and that is playing in this fantastic study that has been done, some sort of adaptation that has to be done but by the CHP for the electrification of the future. So what I want to point a little bit is that being in the Spanish market, there are some sort of things that are not helping us in the road of electrification. And the first one is that, the first one that is helping is that Spain has one of the greatest renewable mix in Europe. So we have like 50%, 55% of our generation based on cheap electricity. The other thing is that this cheap electricity is getting us some constraint in the grid. So if we want to increase our demand, we have seriously problems to get the connection that we request to try to electrify our processes in the industry sector. And the other thing that we are seeing is that we have an energy market that is pretty low. Is the green graph that I have in the middle, the one that is above. We have last year 65 euros per megawatt in the day-ahead market, and for the first months of the year, the first 4 months of the year, we had like 43 euros. So it's lower than what we can see in other European countries. But what we are seeing is that we have a complementary service or restriction market that is getting us higher and higher cost in the primary market. So last year we saw like 16 euros. So our final price for the market was like 81. And the first months of the year it was in 22. So the final price of the market was like 64, 65. And the volatility of this restriction market goes when the prices go down. So what we are seeing from the self-consumption electricity that can provide CHP is that these restrictions and these constraints is helping a lot the transition, because CHP is a capacity that is being connected in the past, that allows some sort of electrification processes that can work in both markets, can compensate the restrictions, and it gets us the flexibility to work when the prices are high, to reduce the cost, to allow some sort of electrification for the capacity that we are getting on the grid, and then can compensate if the restriction market is increasing the cost and the electrification cannot work, because the alternative is conventional boilers, so emitting more CO2 with less efficiency, can compensate this increase on the restriction market, because big renewable sources or projects are getting a lot of energy that nowadays is not being distributed as good as it has to be, because the capacity of the grid that we have doesn't allow us. So we have a reality that show us that this role of transition is a very good point for the CHP, as the study shows. And a little bit it was what I have to point. And thank a lot, Gerald, to let us participate from Spain to help them in develop the study.
Thank you, Ricard. Thank you for your introductory remarks. I'll move on to Valentin Gonzalez. So welcome to the webinar. I believe you have 1 or 2 slides you'd like to share as well. So please go ahead and try to share.
Good morning, everyone. I'm going to share my screen. Okay. Yes. Okay. I think that I'm.
Yes.
I'm sharing my screen. Okay. Thank you, Hans. And thank you to Cogen Europe for inviting us to participate in this webinar and allowing to show our view in the Spanish cogeneration sector. First of all, for those who doesn't know to Ignis, we are an independent power producer. We are based in Madrid. We are vertically integrated, and currently we are developing renewable projects, but also thermal projects for the industry. The main figures, almost 40 gigawatts under development, established in 10 countries, more than 600 people, and 12 gigawatts under management in the generation sites. briefly in a snapshot for the Spanish power sector, as Ricardo mentioned. We are an energy island with a very low interconnection capacity with the rest of Europe. That means we have a particular electrical system that's in the upper left table. Is shown both capacity installed and the electricity generated by technologies according to the TSO, Spanish TSO data for 2025. The electric demand is in the range of 260 gigawatt hours, and the generation is something bigger, is 272 gigawatts. With almost 40% came from intermittent generation as solar PV and wind. In the upper right chart is shown a daily demand and how the different technologies cover this demand. We can in the yellow line we can see the daily demand that we move from 20-25 gigawatt in the valley of the night up to 35 or 40 gigawatt in the peak of afternoon in the rest of the demands and in the rest of the generation side, we see the base load of the nuclear of 7 gigawatts. The intermittency of solar and wind, manageable technologies like combining cycle, cogeneration, and hydro modulating to fulfill the demand area. In negative values, we see the interconnection capacity and the pumping storage, hydro storage consumption. In the lower right chart, we see the volatility in the daily prices in the wholesale market. These figures are from the 1st of July, and we can see how prices trending to near zero when renewable set the market price, and prices above 120 euros per megawatt hour when the natural gas, the combined cycle, set the price. The main challenge for the sector is how to integrate the renewable energy sources, keeping and managing the higher price volatility. We need also the system needs frequency and voltage control mechanism under low inertial conditions, because all the deployment of renewables has less inertia. The system needs more real-time regulation capacity. That's mainly secondary regulation. That is open an opportunity for the cogeneration. And in the future is how to integrate the battery storage in the system. Now, in the cogeneration sector, which is a typical setup of the existing cogeneration plant, where the gas turbine or the engine use gas natural as fuel, produce the electricity. This electricity can go directly to the market, electrical market, but also to supply in self-consumption to the industry. For the heat is recovery, the source gas is recovered in a recovery boiler, and with this recovery boiler have to attend to the heat demand that is shown in a graph. In this graph, that is the variability of we can see the variability of the demand. The main benefits that we have in the past along this year is mainly the security of supply. for the industry, the efficiency, and competitiveness. For the power system, is distributed generation is close. This generation is close of the consumption. That means we have less losses in the system, but also less infrastructure. It's a synchronous generation that can help to stabilize the system, the electrical system. This technology provides the balancing services, adapting to the generation, and they also have been a lever to develop the natural gas and electricity network in the packs. For the our view, how to hybrid the cogeneration with power to heat solution. Mainly can be e-boiler or heat pumps, or even air heating with resistance, electric air heating. The typical setup, but the cogeneration stop when the break-even price, is under the market price is lower of the break-even. In this case, the cogeneration plant have to stop in order to keep the competitiveness in those hours. When the cogeneration is stopped, the heat demand can be covered by the electrical boiler or a heat pump. With the heat pumps in the violin plot, we can see how is distributed the prices of the electricity in green, and also in the right side when the cogeneration plant is running, is in the brown area. When the cogeneration is stopped due to the low prices, the demand is covered by the electrical e-boiler or the heat pumps. The main benefits of this hybridization is for the industry. We continue with the security of supply, is the efficiency, the competitiveness, and decarbonization for those hours when the electrical boiler is the heat is produced with the electrical boiler. For the system, flexibility and integration of renewable for the system, balancing services, distributed generation, and synchronous. Other way to hybrid the plant is by using with power to heat solution, is by using thermal storage, that the exhaust gases of the engines is storage in a battery, in a thermal battery, and when this battery supply the heat demand, and when due to the operational regime is the same as the previous slide, the cogeneration stop when the break-even is when the pool price is lower than the break-even, and we disconnected the cogeneration plant from the heat, and we continue covering the demand with the discharging the thermal storage. The main benefit is the same. It's a way to adapt with the thermal storage to the heat demand. And the last one option is for those cogeneration that reduce the electrical capacity. We have access to the grid that is open to be used with another technologies, such as solar PV, wind in case that there is a resource near, and battery. And the heat side, we can use the same technologies as power to heat solutions. To summarize, To summarize, in the last days, the auction scheme was released by the Energy Ministry. With this framework, we can extend. It's expected that we can extend the regulatory life for the cogeneration sector, allowing us to incorporate a more efficient technologies, becoming the sector more competitive, more decarbonized, more resilient, and less dependent on the global energy markets. And for the new configuration, plant will be a tailor-made solution for each industry. It's going to depend the demand, the profile, but also the characteristics, the remaining useful life, and for the current assets, the efficiency improvement, and the decarbonization road of the industry. And this is for all from my side. Thank you. If there is any question, I'm open to discuss it. Thank you.
Thank you, Valentin. Thank you for your sharing your perspective and what's going on in Spain. And hopefully we'll have an opportunity towards the end of the webinar also to discuss briefly about, as you mentioned in reference to the new auction scheme, which will provide new opportunities for CHP in Spain. So last but not least, I'm pleased to welcome Nikolai. As I mentioned, he's the Senior Energy Manager at CEFIC, the European Chemical Industry Council, so the European Trade Association for the Chemical Industry. So we're very pleased to have you with us and to share your perspective from the chemicals industry, but also from more of a European perspective. So the floor is yours.
Thanks a lot, Hans. Hi, everyone. Good to be here. I don't have any slides. I'll just speak from the heart and maybe react to a couple of the things I've seen here. So frankly, there's a lot that resonated in the different presentations with us and what we're doing in the chemical industry. Just for background, we're the single largest industrial electricity consumer in the EU and the single largest industrial gas consumer in the EU. So it will come as no surprise that we're also the largest / one of the largest CHP users, up there with pulp and paper, depending on what data set you're looking at. So I'm very happy to note that CHP is not just important for us today, but we also see it as a key variable in our decarbonization pathway. And I think we see it largely play out in these two options that were shown in the different presentations. One as an enabler of a hybrid setup, and quite frankly, I am extremely pleased to see the study results, because I've been banging the drum of hybridization as an electrification pathway for years. I think it's the most realistic short to medium term pathway to unlocking that technology. And it's good to have actual facts and figures, especially in a concrete case study from Spain, showcasing exactly how it can be done. And then the second pathway is obviously using the existing asset base of the CHP, but decarbonizing the fuel supply. And here indeed we see biomethane as probably the most realistic near to medium term option to do that. And then obviously the question becomes, okay, great, if this is the sort of drop-in solution that runs on the existing asset base, how do we scale access to that fuel? So I do want to think a bit about how we can strengthen the case for CHP going forward. And because I have a European kind of policy hat on, I mean, obviously my first priority here would be to better recognize the technology in what we're doing in energy policy. Too often still we run into this issue where energy policy is focused on electricity only, or if you're talking molecules, on molecules only, and forgetting this highly efficient hybrid setup that CHPs can provide. We see that, for instance, when we think about state aid policy, Clean Industrial Deal state aid framework, and of course the Heat Decarbonization Bank comes to mind as strong examples of that. And that really emerges as a barrier because with the grid constraints being what they are, with issues of valorizing a purely electrified system, these hybrid setups are either already competitive or near competitive. And that's really what we should support as a matter of priority if we want to reduce emissions. Now, the second point, I think, relates to a lot of the examples we've seen from the other speakers, which is that, hey, actually, with a CHP, you have a lot of options for generating revenue on balancing markets, on offering flexibility, on offering capacity. But what we see right now in practice is that chemical industry is in the business of making chemicals. We're not really in the business of squeezing a bit of arbitrage out of the power system. So what we then need to really scale these sources of revenue and drive the technology is network operators and electricity suppliers to jump in to do some capacity building and offer products on the market which can activate this flexibility, the balancing service, the capacity from industrial players. We believe that that will help to lower electricity system costs, which is important because if we take the Spanish example right now, I mean, balancing costs are what now? Around 20 euro per megawatt hour. And that number is probably only going to go up with the further penetration of intermittent renewables. Now, don't get me wrong, renewables are lovely and we want more of them in the system. But we also believe there's probably a smarter way of doing these things if we tap into the existing potential of industrial sites, and in doing so, offering them another source of revenue. And then lastly, just because I don't want to focus exclusively on the case study of hybrid setups, I think it's important that we think about where to prioritize fairly scarce renewable and low carbon molecules, and as much as possible, direct them towards those sectors which don't really have other alternatives to decarbonize. So at the moment, a lot of the kind of bioenergy is flowing into the transport sector because that's where the regulatory incentives are. Now, in some applications that might make sense, I'm thinking of maritime here. In other applications, when we think road transport, heavy-duty vehicles, I think that makes slightly less sense. And I think it's time that we rethink our kind of incentive architecture and make sure that where there are scarce molecules, we create incentives to drive them towards where they're needed most. And there, I think CHPs on industrial sites are a prime example of that as a near-term decarbonization options for hard-to-abate sectors that would also really help with this competitiveness pressure that industry is currently feeling. So we're still pretty far away from Christmas, but maybe it's my summer wish list. But I think those three things are on there. Thank you.
Thank you for that, Nikolai. Very interesting, and thank you for sharing your perspective and just highlighting the fact that CHP is such an important technology for the chemical sector, but all or many energy-intensive sectors. And so we need to find a way to get the message across to policymakers and recognize the role that CHP plays already today and what it can do in the future. May it be flexible, may it be hybridized, and using decarbonized molecules. So thank you for that. Very interesting. So we have a few more minutes just for a few questions. I don't see anything in the Q&A session, Q&A function, but that doesn't mean we don't have questions. So I'd like to actually start with you, Ricard. Valentin referenced briefly something new and exciting announced by the Spanish government. It's just adopted a new tender scheme for industrial CHP, and maybe you can share a couple of key features of the scheme. And do you, in your view, think it'll be effective in unlocking the potential of CHP in Spain for the upcoming years, looking at classic CHP, but also hybridized CHP?
Well, it's a difficult question to answer. But I would say yes and no. It depends. We have a particular scheme in Spain that it's based in two economical compensations. One is RO, that is compensating operating cost, and the other one is RI, that is getting some sort of revenue from the investment. So we have to analyze a little bit what is going to happen with this particular scheme, because what we are seeing in the proposal that we had from this weekend is that RO is getting lower from what we had. That's because we are looking for more efficient CHPs, so less operating cost to compensate, but we are seeing more RI because we want more things in the CHP to be flexible, to be hybridized, and all of that. So I would say yes and no. It would be cases from yes, and it would be cases from no. And I think that some old CHPs could not go with this new scheme, and a lot of new CHPs can go with this new scheme. So it's a good opportunity, but it depends. It's not bad and it's not very good. It's what we have, and we have to play with that. And I believe that it's not going to be for all, but it's opening the new path for the role that we are looking for CHP.
Thank you for that. I guess what you're trying to say is the devil is in the detail, and you're still looking through everything.
Yeah.
Before we can be sure. Maybe moving on to you, Valentin. So what do you think industrial users need in Spain from an energy supplies perspective? Is it a matter of just energy security, or is it finding a balance between decarbonization, competitiveness, and security, energy security? And how do you find that balance?
I think that with this auction scheme, establish the industrial have to invest in new equipment. This new equipment, the eligible equipment, is not only the traditional equipment such as engines or gas turbine, but also technologies such as for electrification, the heat electrification, such as e-boiler, heat pumps, and thermal storage or batteries, and even carbon capture. That means we have a list of new technologies that we can incorporate with the cogeneration plant. That these new technologies not only give us more and became more efficient, but also became more flexible. And then this flexibility is asked for the electrical system, for the power system. The cogeneration can give this flexibility, but also by improving the incomes of the balancing services, for one hand, but also for the demand, because the demand traditionally in Spain, the balancing services have been provided by generation, but currently is also provided by consumption, such as e-boiler or batteries. It's a way to improve or enhance the income for the cogeneration plant, becoming more competitive. That is at the end what the industry is looking for.
Thank you, Valentin. Maybe Nikolai, from one policy buff to another, maybe we can get into the nitty-gritty. Is there anything specific you think that needs to be changed in the future, especially now that the Commission is looking towards the post-2030 energy and climate framework, and we know that they're going to present soon their impact assessments to their internal bodies, and so maybe from an EED perspective, RED perspective, the ETS, I mean, what do you think needs to be done to encourage the chemical industry to continue to decarbonize, but efficiently and cost effectively at the same time?
Yeah, I think that question probably deserves its own webinar, but I mean, if I were to keep it brief, so we have a very strong framework in place, right, in favor of decarbonization. If I'm thinking priorities for CHP from a chemical industry perspective, I think we have a very ambitious definition of what is high efficiency cogeneration under the EED. So the priority there is regulatory stability and visibility into the future, that we can continue using this asset base to decarbonize our sector. As regards the post-2030 framework for renewables, it ties back to the prioritization of directing those molecules to where they're needed the most. Where at the moment the RED is heavily geared towards the transport sector. I mean, maybe by the time it was written in the 2010s for good reason, but I think the technology has moved on sufficiently that we also need to rethink this incentive framework. And then obviously the big one for next week will be the revision of the ETS. Clearly, a carbon price signal can incentivize decarbonization, but we also see that there is a lingering risk of it inducing carbon leakage when there's not sufficient enabling conditions in place. We think one of the vehicles actually for decarbonizing short to medium term can be CHP. So the question is then, under the ETS, what sort of further incentives are needed to really drive that technology in a way that is also sustainable from an industrial perspective, which will be a big discussion. But I think between this triumvirate of ETS, EED, and RED, we can set a very strong signal in favor of a continued use of CHP, maybe even increasing that use of CHP into the future. But of course, that requires a degree of political will. And we're happy to work together with you guys over the next couple of months to hopefully motivate that political will.
Yes, a lot has to be done, and we're looking forward to cooperating with you. So thank you to our panelists. I suggest we close the panel discussion now and move to closing remarks. So again, thank you, Ricard, Valentin, and Nikolai for your contributions and your insights. It's very much appreciated. So now moving to closing remarks. We're actually quite lucky to have two closing remark speakers. So I'm first very happy to introduce Javier Morales, who is the Director General of ACOGEN, the association representing industrial cogeneration users, and then also Julio Pascual, who is the President of Cogen Spain, and they will both give joint concluding remarks. So gentlemen, maybe we'll begin with you, Javier, and then move on to Julio. So the floor is yours.
Okay, thank you, Hans, and thank you very much to all the speakers and the participants, especially to Cogen Europe for the excellent and high-value study that we performed. And Spain is one of the European countries that has made the strongest progress in integrating renewable electricity. As we have seen last year, 55% of our electricity generation came from renewables, and 75% was CO2-free if we include nuclear. But this success also brings new challenges in terms of security of supply, grid stability, competitiveness, flexibility, and the need to keep industry in Europe. In this context, cogeneration still remains as a high valuable for both industry and also the energy systems. In Spain, cogeneration means industry. It's closely linked to food, chemical, paper, ceramics, refineries, and many other industrial sectors. And without a strong industry, there can be no truly a sustainable energy transition. So the future of CHP is not isolated CHP. It's, as we said, hybrid, flexible, digital cogeneration. For industry, this is going to mean that we are going to combine CHP with photovoltaics, thermal and electrical storage, power-to-heat technologies, biomass, hydrogen, renewable gases. Industries operating CHPs, we are not excluding any technology. We are eager to integrate them all technologies that are able to create value. Okay, and the objective is very clear. It's that we need to achieve the maximum competitiveness in any granularity, both in the short term, hour to hour, and also in long-term scenarios. Okay, so for energy systems, also CHP, we are going to keep on increasing security of supply, decentralizing generation, synchronous power, voltage control, balancing service, and a lower pressure on electricity grids, that we are in a very critical moment, especially in Spain, for infrastructure developments. And cogeneration can also help a lot developing renewable gases and hydrogen and other renewable fuels in a competitive way. So upcoming tenders, I think it's going to be a great opportunity for our industry, and we think it's a model of an example of the future of CHP, a tailor-made, technology-inclusive approach that is going to serve both industry and the energy system. And the message is that cogeneration is not part of the past. It's part of the future with industry and the decarbonized energy systems that we have in Europe. So we are all in the same wavelength. Cogeneration has a key role to play supporting industry, competitiveness, resilience, and decarbonization. And thank you very much.
Thank you, Javi, for your remarks. I'll move on to Julio. The floor is yours. Julio?
Yes, sorry, I was mute. Well, any case, well, thank you, everybody. Thank you, Cogeneration Europe, for this interesting presentation. I think that this is the end of the long work that we have developed in the last couple of years with you guys and with Compass Lexecon and with the rest of the team supporting, well, this new vision of the cogeneration for the future. And I think that this has been very useful for us in Spain to develop a new model for the cogeneration. Let's say that in Spain now we have a new challenge because we have a new model for cogeneration. We don't have the same targets in the past. We have now new challenges to help to the industry. We have now new tools. Cogeneration is not going to work any longer than 6,000 hours per year. It's going to work half of that. And this new vehicle, as in the symbol of the vehicles, of the cars, we have now the hybrid plug-in car available. I mean, we have all clear that the future long term will be everything electrified, or more or less that. But in the middle of the way, we have 10, 20, 25 years to 245 in Spain to say the degradation of the cogeneration with the electricity solutions. I mean, basically heat pumps, electric boilers, heat storage, electric storage. And of course, in the middle of the way, we'll need also to introduce, well, these biofuels. But we have a new paradigm. We have a new model. We have a new way of compensating for the things that we provide from cogeneration that is helping the grid. I mean, and just not only CO2 and energy savings. Well, it's a new paradigm and it's an interesting challenge. It's quite new for us. Let's say that we have now a new model, a new scheme that is going to be finished by the end of this month. By the end of the year, we are going to present proposals, the whole market, according to with the necessities of the industry. But this study of Compass Lexecon shows us that this is the way. It's the solution for the industry are not unique, are variable, and now I think that the integration with the electricity grid, not just with the gas grid, is gonna be the key issue. We need to rethink how to provide solutions to the clients. You know, it's gonna be challenging to work cogeneration with electric boiler 3,000-4,000 hours per year. It's going to be a solution competitive for an industry, chemical, as we have seen today, paper mill, any industry where the cogeneration is working nowadays. So for us, a challenge. I think that we are in some way driving a new solution, not just for Spain, but for whole Europe. And let's hope, as we consider it's going to happen, this new auction process is going to be successful. And we'll talk with you guys in October in our Congress. Because we are going to be in the middle of the auction process that we're supposed to have in November, by the end of the year. So Hans, whole team, thank you very much, and we appreciate your support.
Thank you, Julio. Thank you for your remarks. Thank you for your kind remarks, and we're looking forward to the annual conference in October. So with that said, again, a special thanks to all of our speakers and contributors. It was much appreciated sharing your expertise and your insights. In your experiences with these technologies. And so just as a reminder to all our participants, the recording will be made available as well as the slides Oh, sorry, I see Javier's raised his hand.
Well, yes, maybe if we have just a couple of minutes, I could share with you just very short information about what their upcoming actions. Okay, do you see the slides?
Yes.
Okay, so this is what we are going to start in right now. We already have the legal frame. We are going to do actions for 1,200 megawatts. Okay, it will be 2 actions. First one this year, next one next year, 600 megawatt each. The investment is going to be around 2 billion euros. And we are expecting participants from 100 to 200 companies. These actions are going to be to renew existing plants, but also for new plants of CHP at new sites. Natural gas, CHP, prepare to 10% hydrogen, prepare for a future with renewable gases, and also biomass, CHP. And the good thing, the model that we have been talking all during this seminar is that we're going to include a broad range of eligible investments. Okay, we'll see it in a moment. The action process is this percent of discount versus a referent investment. It's a capex discount. Okay, marginal actions, and this means that CHP with the awarding we will have 12 years for gas with a remunerated scheme, or 20 years for biomass CHP. Okay, and we will be able to construct these plants in a maximum period of 5 years. And this is what we are talking about. It's not only that the eligible investments are the classical generating equipment, turbines, engines, biomass, boilers, and so on, but also all these electrical and thermal storage, electrification, heat pumps, CO2 capture, hydrogen adaptation systems, and also on the flexibility and the grid services, all the equipment for voltage and reactive set points and control, black start capability. So I think we are going to be able to, so every industry are able to construct the combination of the technologies they need to succeed in this energy transformation. Okay, so that was figures. I will send also the presentation to you.
Thank you for sharing that. It sounds like we need to organize a specific country-focused webinar, maybe after the auctions, to share experiences and more information about the scheme moving forward. So hopefully we can still schedule that in by the end of the year. So again, thank you to all our speakers. And yeah, as I mentioned, yeah, everything will be made available online by the Cogen Europe website, the recording, the slides. Just give us a few days to pull everything together and edit the video, and then we'll make you all aware via email that the information is available. As mentioned, there are 5 use cases. So this was the first of the 5, and we're hoping to organize the next heat and power boost webinar in September, and we're looking forward to organizing it with Italcogen, so our Italian National Association. This use case specifically focuses on the pharmaceutical industry, using engines, but tri-generation, so producing electricity, heating and cooling. So look out for an announcement on that, and we're looking forward to working with our national association in Italy to share these results with you coming forward. So in the meantime, I wish everyone thank you, and if we don't connect, wishing you all a very good summer break and looking forward to the fall as we roll out further detailed results from the study. So thank you again. Thank you for your attention, and wishing you all a very pleasant afternoon.
Thank you. Bye-bye.
Thank you all. See you.
Bye. Muy bien.